All right, so Unit 6, Day 5 notes. These are all the topics and objectives we'll be going over today. To be honest with you, very, very honest with you, a lot of times once it comes to factoring, these bottom ones with factoring, it's a lot of number sense. If you are not comfortable with factoring, it's probably one of the more important topics. You really, really have to practice. It's almost like trying to teach you how to play basketball or something. It's something that it doesn't matter how much you watch it, you actually have to practice it. That's what Alex is great for. You have to get that practice in if you are uncomfortable with it. It is just a very, very number sense type of thing where you have to be able to see um, basically like common multiples of something. But we're going to go over it, but it's just something that if you don't get it, just takes a lot of practice. So I just wanted to warn you. All right, so we're starting where we kind of left off last time. For the most part, we are going to be multiplying kind of like what we did last in the notes for day 4. For this particular one, you're going to be multiplying this 3b times b squared, 3b times -5, 3b times -6. And then you're going to do the same thing with -4. So 3b times b squared is actually going to be 3b cubed, okay? Because you remember this b has a 1 and these have the same base, so you add the exponents. So 3b times -5b is going to be -15b squared, okay? And then the 3b times -6 there is going to be -18b. And now you have to move on with the -4 times b squared, -4 times -5b, and -4 times -6. -4 times b squared becomes -4b squared. -4 times -5b, two negatives, positive 20b. And then -4 times -6 becomes positive 24. Okay? Two negatives make a positive, and the signs are very important. One wrong sign, the whole thing is wrong. Okay? So now we're going to combine like terms, and usually, like you've seen with the other ones, the very ends don't have the terms that are like. But the inside, the middle, we can kind of combine like terms. -15b squared, -4b squared. I'm going to leave this 3b cubed alone, and -15b squared and -4b squared became -19b squared, -18b, positive 20b. Okay, we can combine those, and that becomes positive 2b. And then the plus 24 at the end doesn't have the like term. And again, this is in standard form because degree is 3, 2, 1, 0. Okay, goes from greatest to least for the degree, and we talked about degree in earlier notes. All right, so let's move on to this one. This one is a beast, okay, only because it's a 3 terms times 3 terms. They call it trinomial. Trinomial times a trinomial. Ugh, nasty word, but we are going to do it. So 2w times 6w, 2w times 5x, 2w times 2. So 2w times 6w is 12w squared. 2w times 5x, 2 times 5 is 10. Sorry about that. 10, okay, xy, xw, or wx, whichever one is fine with you, as long as you're consistent. And then 2w times 2 is positive 4w. Multiplying the numbers. Now we have -7x times 6w, -7x times 5, -7x times 2, -7x, this becomes -42xy, okay? -7 times 5x, this becomes -35x squared. -7 times 2 is -14x. We're still going because we still have this 6. So 6 times w, 6 times 5x, and 6 times 2. So let's do that. 6 times w is, I'm just going to move it on down here, 36w. 6 times 5x is 30x. 6 times 2 is 12. Woo, that is a lot. Okay, and again, usually it's that first and last number that don't have any common factors, but let's see. Okay, I see that 10xw and negative 42xw kind of go together. So I'm going to leave that to 12w squared, and I'm going to combine those two, which now becomes negative 32xw. Now, let's see what else. I see 4w and positive 36w. Those look like they go together. And that becomes, what, 40w? And this looks like it's alone. It has an x squared. That's a w squared. Nope, doesn't go together. Oh, but I see this, 30x, negative 14x. And I want to say 16, so this becomes positive 16x. Okay. Oh, I forgot about this 35x squared that's alone. And also that 12 is alone. So let's look at the degrees here. Make sure the degrees are going from greatest to least. Okay, the degree here is 2. We know from the exponent. What is this degree? It has an x and a w. Both degrees are 1. So remember, your terms are separated by pluses and minuses. So this is the whole term, 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 and term. And we did that in another day for notes for degree. So this is, degree is 2. Degree is 1 and 1 is 2. Degree is 1 because it only has a w. This degree is 1. This degree is 2. And this degree is 0. So this 2 is kind of out of place. You can put it in the front. It doesn't, like, these are all the same degree, so it doesn't matter which goes first. So you can put 12w squared minus 32xw and then minus 35x squared. Remember the negative, the number, the sign in front of it goes with it. And then the rest of these can just go 40w, 16x plus 12. Again, I'm putting it in standard form, highest degree to lowest. And there you go. Okay. So, whew, that was that. All right, so now let's move on to dividing. And remember, when you're dividing, if the bases are alike, you subtract. But look at this. This looks kind of funny because it has a polynomial, binomial on top, polynomial on top, trinomials on top. Let's see how to do that. So when you're seeing something like this with the pluses in between, this is actually a plus. Can't tell. What you're going to do is kind of split them up. This is what I would do. 9x to the 5th over negative x squared plus 3x squared over negative x squared. That's what I would do, I think. And then what I'm going to do is, I don't like that negative at the bottom. That is just ew. I'm just going to subtract the exponents here. So this becomes 9 over, remember that's a negative 1 under here, okay? And I'll do something with that later. But remember, when the bases are alike, you would subtract the exponents, kind of like that. Plus, I would make that, again, negative 1, and that's a 3 up top. These two cancel each other out. So that's cool. And 5 minus 2 here. So when you're dividing 9 divided by negative 1, guess what that makes that? That makes that negative 9. Okay? So 9 divided by negative 1, if you even put it in a calculator, okay, 9 divided by negative 1, you get negative 9. Okay? So that's why that became negative 9. And then x, 5 minus 2 is 3. So that's how I got x cubed. And then 3 divided by negative 1 is negative 3. So if it's negative 3, it's going to be minus 3 there. Got that? So you have 9x cubed minus 3. That's what I got for my answer there. All right, so now let's move on to the next problem. And we're going to solve it the same kind of way as we solved the first one. So again, you're going to take 36x to the 7 divided by 4x cubed minus 28x to the 4th divided by 4x cubed plus 8x cubed divided by 4x cubed. Okay, so basically I split this up into separate problems, and then I'm going to solve them like that. Okay, so 36 divided by 4, you should know, but if you have to use your calculator, that's fine, is 9. So I would divide 36 divided by 4, we know we get 9. And then again, x to the 7 minus 3, because they have the same base, take the first number and the top number and subtract it from the bottom number. Minus 28 divided by 4 is 7. And then you say x to the 4 minus 3, because I'm taking the top minus the bottom. And then plus 8 divided by 4 is 2. Those cancel out, so they're gone. So my answer would be 7 minus 3 is 4. So it's 9x to the 4th minus 7x, because it's 4 minus 1 is 4 minus 3 is 1, and then plus 2. That is going to be my answer there. Okay. So again, with this particular one, it looks very different, and I'm not going to really do it, but I want to show you that if it has a division sign in between, just divide it by negative 3x like that, okay? And then do it like we did those. So all you're doing is going to rewrite it, and then do it like we did those, okay? So this one has a little star, even though it looks like a star. This is, and it's very, very similar. So we're saying 4b squared x over 2b cubed x squared minus 18b to the 5th x cubed over 2b cubed x squared minus 16b to the 7th x to the 5th over 2b cubed x squared. Okay, so we're going to solve these just like we've been doing. All right, divide the numbers. 4 divided by 2 is 2. Subtract the exponents. B to the 2 minus 3. X to the 1 minus 2. So I'm taking the top number and subtracting it from the bottom number. Minus 18 divided by 2 here is 9. Again, b to the 5 minus 3. X cubed minus 2, and this is just because I want to be consistent. 16 divided by 2 is 8. I'm keeping these signs in between. B to the 7 minus 3, and x to the 5th minus 2. Now let's kind of solve those out to see what those look like. So this is going to be like very, very strange, but we're going to get through it, okay? So this becomes 2 to the b. The b is negative 1, because 2 minus 3 is negative 1. X is 1 minus 2, which is negative 1 as well. Minus 9b, 5 minus 3 is 2. X, because 3 minus 2 is 1, I'm just going to put an x. I'm not going to put an x to the 1. Minus 8 b to the 4th, because it's going to be 7 minus 3. And then you have x to the 5 minus 2, which is what? 3. X cubed. Okay? So now all of these look okay and fine. I'd be okay with this answer, but we cannot have negative exponents in our answer. And that, we did this one time earlier in another notes, But I wanted to show you that if it has a negative exponent and it's up top, it goes to the bottom. If it has a negative exponent at the bottom, it goes to the top and it becomes positive. So your answer here is going to look crazy, but this is the answer. 2 over b and x, okay? Because that b has to go to the bottom, become a positive exponent. That's a positive 1. X went to the bottom, became a positive 1 at the bottom. Minus 9b squared x, everything else stays the same, okay? Everything else stays the same. It's just that first term has those numbers at the bottom, and that's because it had a negative exponent. If they have positive exponents, they just stay the same. They just stay up top like the ones here, okay? Now, this is where the whole number sense I was talking about comes in, kind of. It's very difficult to teach this if you don't have like a whole bunch of number sense, or you can't see, not to say that number sense like meaning you don't have any sense, but you have to be able to see patterns and definitely see factors once they come along, and you'll see when we're factoring. It is just a mess. But a lot of practice makes it very much way more easier if you practice, as opposed to just thinking that it's going to come to you. So they want to see what's the greatest common factor. And basically a factor is two numbers that come together to multiply to give you whatever number this is, okay? So in this case, our factors of 22 are 1, 11, and 2, okay? So basically 1 is going to be a factor of everything. 11 times 2 is 22. And I want to say that's those are the only factors of 22. All right. Then we have 35. We know 1, like we said, 1 is a factor of everything. How do you get 35? 5 times 7. Okay. Any other ways to get 35? I don't think so. Okay. So it says, what's the greatest common factor? So what's common between these two? It really looks like just 1. Okay. So the greatest common factor here would be 1. And again, it takes a lot of number sense. Again, just like knowing these factors, and the more you do it, the more you'll see it, the more you'll get used to seeing it. Okay. All right. So, and you'll see why that's important. So we're going to start here with this factor, because they want to basically, you're looking for the greatest common factor. What is common between them? And 27's factors are 1, of course. Okay, you know that 3 times what? 9 is 27. Those are all factors of 27. Okay. So you have 1, 3, and 9. Are there any more? I think that's it. And of course, the factors of 3 are 1 and 3. 3 is prime. So what is the greatest common factor here? As you can see, it's 3. Okay? So how I would do this, really, to show you how to kind of do this, is what I usually do is break 27 down. So I'll break 27 down into 3 times 9, and then I'll break 9 into 3 times 3. Okay, this kind of helps when you're doing this way. So 27 is actually 3 times 3 times 3, and we know that 3 is 1 times 3, okay? So what is common? We said what was common was 3. 3 is common. That is what's common between them both. All right? So we have the 27, and you have the 3. Because 3 is 3 times v, because it's 3v. Okay? So when I took out the 3 there, when I took the 3's out, what was left? What is left over? Okay? So what is left over here is 3 times 3, if you can see that. For the 27, the 3's were common, so I took them out and I put an X through them. And there's a better way to do this. I'll do that for this one. So once I took that out, what was left over here was 3 times 3, which is 9. Plus, what was left over here was just the v. So when I took the 3 out, 9 plus v is left. I have a better way of doing that. Okay, that was kind of confusing. And let me show you a better way this way. What I would do is I would draw 8u. So 8u is there. 28 is the other factor here. Okay, so we have 8u. I put it right here. 28 as the other factor here. And I'm going to break it down into its very prime factors. So 8 is 2 times 4, okay? And usually I do it this way, like I did it there. 2 times 4. And once you break it down, you can mark it out. 4 is 2 times 2. And that's 8. So 8 is 2 times 2 times 2 times u. 2, 2, 2, and then 8u. So I put the u next to it. 28, okay, 28, if I say 28 is going to be 14 times 2, and I know 14 can break down into 7 times 2. I don't think anything else can break down. So 28 is 2 times 2 times 7, okay? So I broke all down to prime numbers. I broke 28 down so it can't break anymore. I broke 8 down so it can't break anymore. And then I wrote those factors out. That's what I did there. Now, what is common between them, okay? So what is common here? 2 common. So greatest common factor here is, I see a 2. And when you circle it twice, you only write it one time. So it's common once right there. But I also see another 2 here. Also common there. Okay? So anything else common doesn't look like it. So now we have this is common, this is common. So basically 2 times 2 would be 4. So the greatest common factor is 4 between those 2. So when I take the greatest common factor out of 4, what is left over? Okay, look at 8u. I took the 2 2's out. I took that 2 and that 2 out. What's left over? 2u. Plus, when I took those 2's out for the 28, what was left over? 7. 7's left over. This is how you're taking out. You're taking out the 4. So 4 is the greatest common factor. And what's left over is what I leave inside the parentheses. So this is a better, to me, example of how to do it than this, okay? So if we go down here and they want to know, find the greatest common factor, again, I could probably do it the same way. If I had 11w squared, 11 is 1 times 11. So I'd have 11w squared. And if I had to break that up into, it's 1 times 11 times w times w. And if I had 13c to the 4th, basically that's 1 times 13 times c times c times c times c, c to the 4th. Greatest common factor, because that's what they're asking me for, is what's common between them. And as you can see, the only thing that's common between them is 1. Okay, and you only write it once when it's common. So 1. And all they want here is a greatest common factor. All right, there they wanted you to actually factor, then you take it out and then what's left over. So in this case, they just want the greatest common factor. Let's go down here. So 14y cubed v to the 7th. That's one factor. I'm going to have to factor that all the way out. And then I have 30 y to the 6th, v to the 7th, u to the 4. Let's factor that. Okay? So 14 is going to give me 2 times 7. So 2 times 7 times, and then you know you have y times y times y. I am not going to do v to the 7th. I'm not going to write that 7 times. But that's what you have. 30 is 15 and 2. 15 is 3 times 5, and that's it. So you have 2, 3, 5, y, y. You keep going with the y's, and then you know you have b to the 7, and you have u to the 4th. Okay? So what is the greatest common factor there in that particular situation? I can see that 2 is common. Okay? So I'll write it one time. If it's common, you write it once. Anything else you see? I see 1, 2, 3 y's common. Okay? So y cubed, because that's y 3 times. Looks like b to the 7th is common. Anything else? There isn't any more y's up here, so it can't be common. Nope, that looks like it's it. So the greatest common factor in this situation is 2y cubed, okay, and then b to the 7th. And again, this takes some time, okay? I could have honestly just looked at it, but it takes some time to kind of figure it out if you want to try to do it the long way, just to kind of get the hang of it. And then once you get it, you'll just see it really, okay? Now, I'm going to just look at this one, and I want to see if you can kind of figure this one out. It's 4b squared plus 15b cubed. All right, 4 and 15, they don't look like they have anything in common. 4 is 2 times 2, 15 is 5 times 3, that doesn't work. But what about the b squared and the b cubed? Okay, so I know 4 and then b squared is b times b, 15 doesn't have anything common, b times b times b. What would be common? Looks like b squared. Okay, one b and then another b, but this one doesn't have a third b. They have to be in both. So b squared is what would be common, the greatest common factor there. Okay, so b times b. And again, it's just kind of looking and seeing. After a while, you just see it. Believe it or not, it takes time, but you just see it after a while. And at first, it is just not easy, but it is something that you will have to develop with time. All right. So for this one, I'm not even going to really go into all of these. I'm going to say that if it's 9w squared minus 7w cubed, the greatest common factor here, if you can see it, I hope you can, it's going to be w squared. Okay, because it has a w squared there, a w cubed here, and the same thing we did there, where there's 2 and there's 3. These 2 would be the common. All right, and if you have to do it that way, I'm okay with that, as long as you get the answer. Got it? Good. All right, so let's go on to the next, and I spent some time on that because it's so important that you kind of get how to do these. So for the factoring the following expressions, it's the same thing we just talked about, but let's kind of go through it. So like I said, 7u to the 9th, so this will be 7u to the 9th, and b to the 5th is up here, x to the 8th. And then this one, again, if I had to break 28 down, it'd be 2 and 14, and 14 would be 7 times what, 2, okay? So you know that 28 became 2 times 7 times 2, and then you have u squared there, okay? And you have b to the 6th there. Just make sure it's clear. All right. So if you're looking for greatest common factor, I can see 2 7s. So I know that at very least, I know it's a 7 there. Now, there are 9 u's up here and only 2 down here. So basically, the 2 u squareds would be common, but then there'd be like, what, 7 u's kind of left over, okay? So I only took 2 from that 9 because it had to match up with it. What about the b to the 6th? It looks like this would become b to the 5th There'd be 5 here, but there'd just be 1 v left over, okay? So v to the 5th, no x's down here, so you can't kind of match those up. The greatest common factor would be 7u squared v to the 5th, but they want you to factor it, okay? So now that you took out the greatest common factor, we took them out, what is left over? That is what's important. That's why this part is important, because then you can look and see what's left over. We took the 2 u's from the u to the 9th, so now we have u to the 7th. U to the 7th is left over in that first factor, and x to the 8th. Okay, the sign up here stays the same. So minus, what's left over here? 2, I see 2 times 2, 4. Okay, and then there's 1v left over there. And again, I don't expect this to be easy. This course actually moves in a very, very quick manner in kind of difficult situations, but you can get this. It just takes a lot of practice, and Alex will give you that practice. You have plenty over here to kind of practice on with the key coming up. So just do your best. I know that you can do this, okay? Now, for this one, it says, write the expression by factoring out the x minus 7. With this one, it's kind of leading you into factor by grouping. If you have this x minus 7, it wants you to factor it out. Basically, what they're saying is put it first, x minus 7 first, okay? So basically, what you've done essentially is the opposite of the distributive property. You've taken it out of both, okay? So now it's gone from both of those. It's at the beginning. What is left over when you took it out or you factored it out? 7x minus 5, okay? As you see here, 7x and then minus 5 is left over once you took that x minus 7 and put it up front, okay? And you're going to be doing that in a minute. Same thing here. Rewrite the spectrum by factoring out x u plus 5. So if you put u plus 5 up front and take it out, factor it out of both of those, what's left over? 3u plus 5. That's what's left over there. Okay? And now the factor by grouping. Again, it kind of leads you into this situation. That's what these notes are kind of for, to give you some background on it. The factor by grouping is basically taking this top portion right here, and then it's going to basically the next level. Once I look at, when you're factor by grouping, you are grouping the first 2, and then you're grouping the second 2. Same thing here, grouping these 2, grouping these 2, and I'll show you what to do there. So when you're grouping these, you're finding the factors, the greatest common factors of these 2, and then the greatest common factors of these 2 separately. So if I had to take the greatest common factor here, again, 6v cubed would be what? 2 times 3 is 6 times v times v times v. And the second is 7 times 3. 21 is 7 times 3, and then v times v. So what is common? I see 3. 3. How many v's? 1, 2 v's are common. V squared. All right. So if I took out 3v squared, what would be left over? At the top, it looks like 2v plus 7. Okay. That's what's left over after I took out my greatest common factor. Then you do the same thing over here. 14 is 7 times 2 times v, 14v. And 49 is 7 times 7. So the greatest common factor there looks like it's just 7. Plus 7. That's the greatest common factor. What is left over? The top number, it looks like 2v plus what's left over here? 7. And as you see 2v plus 7, 2v plus 7, that's what's going to happen when you're factoring by grouping. If these two things are not alike, then you probably did something wrong, okay? And just like we did up here, where they wanted you to take out the u plus 5 and put it up front, and then what's left over, you're going to do the same thing here. We're going to take out what's common, which is 2v plus 7, put it up top. Now, when we did that, those two go away. What is left over? 3v squared plus 7. That's how you're going to do that factor by grouping. Okay? So kind of same situation here, but the only difference is that those two are negative. When you have both of them are negative, when you take out the greatest common factor, the greatest common factor is negative. I'll show you, and then the rest of the stuff comes positive. Let me show you that. So first and foremost, x times x is x cubed. We're doing the greatest common factor z2. X times x is x squared. What is the greatest common factor? It looks like, if you see it, those two x's, x squared. Greatest common factor, x squared. When you take x squared out of this situation, what is left at the top? X plus, when there's nothing left over, 1 is the number that's left over. When there's nothing left over, like here, both of those got taken, then there's 1 there, okay? Now let's do this one. 7 is 7 times 1 times x, and this one is just 7. So the greatest common factor is 7, but when they're both negative here, the greatest common factor, so the greatest common factor here is 7. When there's two negatives here, -7, the greatest common factor, whatever it is, becomes negative. That means whatever's left over, so 1 times x is x, nothing left over here is positive. Okay? When I took out a negative greatest common factor, it became these two became positive. So now, just like earlier, that is that x plus 1 is the same. So I'm going to take that and put that in front, x plus 1. It goes away. What's left over? X squared minus 7. Okay? Squared minus 7 left over. And that is your answer for the factoring by grouping. So this is a lot, I know, but last page, okay? Last page. Again, we're going to factor by grouping. I am going to let's go ahead and try to, for this particular one, what they want you to do here, they really want you to first, I want to say put it in order by degree. At least that's what they want you to do. It looks like they want you to kind of flip them around so that they're in the order to make it work for you. I'm not sure. Yeah, let me put this in an order that would make it like group it so that it kind of works better. Okay, I believe that's what they would want you to do there. I'm going to make it so that it's going to be -7y squared minus 28y, and then so I put these together, the y's together, and I'm going to put this over here with the u. So I'm going to say plus yu plus 4u. Okay, so basically I grouped the y's together, and then I grouped the ones with the u's together. Okay, because then that's going to make it so that it kind of works out with the factoring by grouping. And because they're adding and subtracting, you can flip them around any way you want. You want to make sure you group them in a way that is helpful to you, and you can kind of see the numbers in this particular thing, especially like I said, when you've done this a lot. takes a little time, and I think Alex explains it well, but they take a little time, but you can figure it out once you have done these a lot. So I group them in the Y, put the Y's together, and I put the U's together. So I'm going to do factor by grouping. Again, when they're both negative, that means my greatest common factor is going to be negative, and then it turns to positive. So 7y squared is 7 times y times y. I know that. 28 is 7 times 4, which becomes 2 times 2, but it really doesn't need that, times y. So my greatest common factor there is going to be 7 and y, okay? 7y. So when I take 7y out, negative 7y out, excuse me, negative 7y, because both of these are negative, so I'm going to take out the negative greatest common factor. What is left over is y plus 4, okay? For this one, it's going to be y times u over 4 times u, and I'm taking out the u's, okay? So my greatest common factor is u. And so I'm going to put plus u here. What is left over? Y plus 4, okay? So again, y plus 4 and y plus 4 come to the beginning. Okay, when they have those in common, I can put it front. What is left over? Negative 7y plus u there. Took me a little while to figure that one out, but that's how you do that one. And I will definitely let you do this one. This one is the same concept. I really want you to practice that. So go ahead and try that one on your own, and the key is going to be in Canvas, okay? Now, factoring, I have a very nice little trick for, it's not really a trick. What it really is a thought process that kind of works with factoring if you're not comfortable with it. So this is how it kind of works. And maybe you could write this down. This is like a nice little trick, and I've taught this for many, many years, and students really, really liked it. Once they started to get to understand it, they really liked it. So if you look at the last number, and you'll understand what I'm saying with it, okay? So let's say the last number here. If the last number is positive, okay, I'll ask you same or different, and positive means same, okay? So positive is same. That's what I'm looking for when I say same or different. Negative is different. What do I mean? If the last number is positive, then you're either going to have 2 positives in between for factoring, or 2 negatives in between for factoring. If the last number is negative, like this one, you're going to have 1 positive, 1 negative, okay? And it all depends on what's happening with that middle number. So this, if I say same or different, you would say this is same. Why is it same? Because this last number is positive. We don't care what the middle number is. Last number positive, meaning that they're either going to be both positive or both negative. In this case, because the middle number is positive, you're going to have y plus something, y plus something, okay? Just hang on with me here, okay? If you've never seen this before, or you've never had the factor before, this is going to be kind of hard at first, but once you start getting the hang of it, I promise you, it will come to you, okay? So the last number is positive, which means they're both going to be either positive or negative inside here. In this case, because the middle number is positive, they're both positive. So if it's positive on the end, but it's negative right here, then they're both negative, okay? So this means the last number being positive means that it's the same sign, either both positive or both negative. In this case, it's both positive because the middle number is positive. So what are the factors of 24? Because I said same, okay? Same is also adding to get the middle number. Different is subtracting to get the middle number. Okay? And I've taught this many years. So, and I've taught it to all high school age students. I know that you can get this. So same meaning, so that means I'm going to add to get your middle number. So what are your multiples of 24? The add to give me 11. 24, 2 times 12. 2 times 12 is 24, yes. But 2 plus 12 is 14. So it's not going to be that. Okay? Looks like it's going to be 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. That is going to be our answer for your factoring. Okay? We didn't have a star by that one. We did that one. Try this one. Same or different? We're going to say same. Okay? Same meaning whatever this is, it's going, both of these are going to be whatever that is. So if it's a plus right there, they're both plus. Okay? If there was a minus right there, they both be minus. What are your factors of, when you're saying you're adding to get the middle, what are your factors of 4 that add to give you 5? 4 and 1, because there's only, oh yeah, there's 2 and 2, but 4 plus 1 is 5. That's how we got that. That's actually a plus right there. I don't want you to think that's a minus. That is a plus. That's why this is plus and plus. Same sign. Okay? Let's look at this one. Same or different? Same. Why? Because we're only looking at the last number when you say same. If the last number is plus, you say same. That means you're going to add to get the middle. Both of them now are the same sign, but they're both negative because that middle number is negative. Same, if the last number is positive, you're going to have either both positive or both negative. This means they're both going to be negative, the same sign. Plus means you're going to add to get the middle. So what are multiples of 4 that give you 5? We already said that. 4 and 1. Okay. All right. Let's try this one. Same or different? Last number is negative. Different. Okay. This represents the bigger number. Different meaning 1 positive, 1 negative. That's what different means there. Okay. If the last number is negative, then you're going to have 1 positive, 1 negative, and you're going to subtract to get the middle number. So what are your multiples of 12 that subtract to get you negative 1? So we know multiples of 12 are 1 and 12, 2 times 6, because 2 minus 6 is 4. That's not going to work. 3 and 4, 3 minus 4 is 1. Good. Your bigger number has to have the sign of the middle number. So if we said 3 and 4, our bigger number is 4. So our bigger number has to be negative. And yes, it has to be negative. If it's not negative, it's not going to be correct. If 3 was negative, it would be wrong. Okay? Same concepts here for these. Okay? Same concepts here for these. But it just has this extra number at the end, and I'll show you how to do that. So let's follow this like we follow anything else. Same or different. You'd say same, which means they're both going to be negative. Same meaning the same signs in here. But you add to get the middle. What are your multiples of 18? To add to give you 11. So 18 is 6 and 3. That's not going to work. 9 and 2. That looks like that'll work. 9 plus 2 is 11. So we'll have 9 and 2. Okay? They're both negative, so it doesn't matter which one it goes. But the only difference here is this little y at the end. You just put y's at the end. That is it. Because once you know how to factor, you are good. All right, same or different there? Different. Different meaning 1 positive, 1 negative. Okay? And remember, you're going to subtract to get the middle. The bigger number is going to have whatever this sign is. In this case, it's negative. The bigger number is going to be negative. So what are your multiples of 6 that subtract to give you negative 5? So we have 1 and 6, 2 and 3. 1 and 6 is it, because 1 minus 6 is 5, or 6 minus 1 is 5. So your bigger number is negative. So it's going to be 6 is negative, 1. And then when it has the extra little letter on the end, that's when we put that. Up here, we didn't have the extra letter there. Okay? So practice this, practice this. If the first time you've seen it, it might be confusing, but I promise you, if you practice it, you will get it. I have gotten so many students through factoring